Hi everyone, so we're going to start some work on what's called uniform acceleration, and all that means is that the acceleration is constant. Okay, so we're going to start with some notes, a little bit of definition. So basically, if a constant force, so a force that's not changing, it's not variable, if a constant force acts on a body, it will accelerate uniformly, so the acceleration will be constant, so it'll be accelerate uniformly in the direction of the applied force. Okay, so that's just our definition. If there is some sort of force acting, it's going to cause an acceleration, and if it's a constant force, it's going to be a uniform, a constant acceleration. Okay, and what we're going to look at is what's called the suvat formula. And these formula, they're only going to apply if the acceleration is uniform. So we've got to be really careful when we finish mechanics and we get to look at some exam questions and past papers, we're looking for uniform acceleration for this method to be applicable. So we're going to look at what's called the suvat formulae. Okay. And first of all, let's just have some notation definition. So S, U, V, A, T, what do they stand for? So S is our displacement. U is our initial velocity. So the velocity at the start of the motion that we're looking at. V is our final velocity. So what velocity is it reached by the end of the motion that we're looking at? A is our acceleration. And in all the questions we're going to do in this chapter, it's going to be constant acceleration, and T is the time taken for the part of the journey that we're looking at. Okay, so let's just have a little think about our first couple of formula here. So a couple of things that we should already know from GCSE. One is that our constant acceleration, well, what is acceleration equal to? It's equal to the change in velocity divided by the change in time, the time taken. And that should be something we know from GCSE, change in velocity over change in time, the rate of change of velocity, that's what acceleration is. So let's do that, but using this notation. So constant acceleration, that's A. Change in velocity, well, that's going to be the final velocity minus the initial velocity. And the change in time, the time taken, is T. Okay. So if our initial velocity is 0, basically the time taken is if we start at 0, the time taken is this T. So there's our formula. And we're just going to rearrange that into the form that it's normally given in. So I'm going to take the T up, I'm going to take the U across. So I'm going to end up with V equals U plus AT. And that's our first suvat equation, our first uniform constant acceleration equation. Okay. So let's look at the second equation. I'm just going to move that up slightly. So a second equation, again, let's think of something that we know from GCSE. Average speed. Well, what is average speed equal to? Average speed is equal to displacement over time. Okay, so let's look at this one then. Displacement over time, well, that's just S for displacement over T for time. And our average speed, well, the average speed is going to be the initial velocity, maybe we should have called that velocity actually, average velocity there, U at the start, V at the end, so the sum of our velocities divided by 2 to give me the average. And then again, if I just rearrange this into the form that's normally given in these equations, I'm going to take the T over, so that's going to give me S equals U plus V over 2 in a bracket, multiplied by the time T. And that's my second suvat equation. Now what I want you to do for the rest of the lesson before tomorrow's lesson, I'm just going to move that up again so that hopefully you can see these two. What I want you to do is to try and derive the other suvat equations. And what I want you to do using these two then, so if I call these 1 and 2, I want you to use these two equations, and first of all I want you to look at eliminating T. So make T the subject of one, sub it into the other, play around with the algebra. What you should end up with is this. So V squared equals U squared plus 2as. But I want you to have a go deriving it to convince yourselves that's where it comes from. The second one I want you to look at is eliminate v. And then that should give you the equation, if you play around with the algebra a little bit, s equals ut plus a half at squared. And lastly, our fifth equation, the third one I want you to have a look at, is eliminating u, make you the subject, sub in, play around the algebra, and I want you there to end up with s equals vt minus a half at squared. Okay, so have a go with that, please. And then in tomorrow's lesson, we'll look at using these equations in a load of different questions.